करने के लिए पूरे खेत में खुद ही काम करने लग जाती है। ऐसा नहीं कि जो उसका पति था वो काम नहीं करती थी, तब भी काम करवाती थी, लेकिन उसकी जो वो और निखर कर आता है, उसकी भूमिका और अहम हो जाती है जब पुरुष उसके साथ नहीं है।
तो इस तरह से पेंटर्स जो है, महिला पेंटर्स जो आना शुरू किया, जामिनी रॉय हुआ, अब आजकल के जमाने में अंजलिला मेनन हो, चाहे ये हो, अपर्णा कौर हो, तो ये लोग जो पेंटिंग की बातें करते हैं, महिला के अलग दृश्य, अलग चित्र सामने लाते हैं, अलग दशा सामने लाते हैं, अलग उनका जो समाज में रूप है वो सामने लाते हैं। हम सिर्फ राजा रवि वर्मा की पेंटिंग के बारे में नहीं सोचते कि सुंदर हो, ग्रेस एलिगेंस हो, उसके अलावा भी हम सब बहुत सारे चीजें देखते हैं पेंटिंग की बातें करते हैं। इस देश में हमने स्कल्पचर्स देखे, सबसे बड़ा रिप्रेजेंटेशन जेंडर का जो है अक्सर। आप अगर मंदिरों की बात करेंगे, मंदिरों में हम देवी देवताओं को पूजा करते हैं, बहुत सारी देवी के टेम्पल्स हैं। हम लोग अगर गंगोत्री की बात करें, गंगोत्री जो होती है वहां से लेकर एक गंगा जहाँ खत्म होती है, वहां पे काली घाट में काली माता की पूजा होती है। तो इस तरह से गोदावरी में जो पूजा करते हैं गॉडेस तुंगाभद्रा की, उस तरह से हम देखते हैं ये सारे जो देवी देवियों की पूजा होती है, पूजन होती है, जो रिप्रेजेंटेशन स्कल्पचर्स की, आइडॉल की, वहाँ पे हम महिलाओं को ही लिया जाता है।
चलते फिर भी जानना चाहूंगे कि जेंडर एंड मीडिया एक ऐसी कोटेशन, एक ऐसा शब्द है जो हमारे जितने सुनने वाले भी वो आसानी से समझ सके।
देवी के टेम्पल्स में हम लोग अगर गंगोत्री की बात करें, उनकी किताब से है। अब कौन सा जेंडर है गंगा जहाँ समझना हमें है।
बहुत शुक्रिया हमारे इस कार्यक्रम में
गोदावरी में जो पूजा करते हैं।
You are listening to a program titled Gender and Media. The content coordinator was Dr. Himadri Roy, Associate Professor from School of Gender and Development Studies, Ignou. Participants of the program were Dr. Himadri Roy, Associate Professor, and Dr. Smita Patel, Assistant Professor from School of Gender and Development Studies, Ignou. The program was anchored by Savita Rana, technically supported by SK. Program produced by Ashwin Hoog and edited by Gauri Joshi. This was an EMP speaking presentation. You will listen to a program titled Gender and Media. The content coordinator was Dr. Himadri Roy, Associate Professor from School of Gender and Development Studies, Ignou. Participants were Dr. Himadri Roy, Associate Professor, and Dr. Smita Patel, Assistant Professor from School of Gender and Development Studies, Ignou. The program was anchored by Savita Rana, technically supported by SK Jain. Program produced by
I'm going to discuss about challenges we face in urban areas to food security, to the problem of food security. Millions of poor in our country. There is mass poverty and the levels of food consumption are low. And half the adults and half the children in our country are undernourished. Given this, it is clear that a vast majority of our population are insecure with regard to food and nutrition. Now, let's highlight some of the indicators of income poverty and calorie consumption levels of our population. Now, we have something like 260 million population under what we call the poverty line in India. The 1999-2000 Planning Commission report says that there are 67 million in urban India who can be termed as poor. Now this poverty line is nothing but the income that is required to purchase food items which gives you a minimum calorie intake. So that is set at 454 rupees per person in urban India. So we have nearly 67 million people who do not have even this 454 rupees per month. So that is the extent of poverty in our country. And we also realize, many studies have shown that food security affects is not only for those who are income poor, but it is also for those who are, for a much larger section, who are not actually income poor. Many studies have shown that nearly 70% of our rural households and about 80% of our urban households do not have the requisite calorie intake. And what is also depressing is that the consumption levels are actually going down compared to early 70s to early 90s. And nearly 50% of our adults and about 55% of our children, as was mentioned earlier, are undernourished. Given this, let us see what is the level and magnitude of food insecurity in urban India. Now, it's very clear that the problem of food security is pervasive. It is there in rural areas and it is there in urban areas. And I'm today going to be talking about the problem in urban India because I've been part of a team which at the Swaminathan Research Foundation, where we have produced a food insecurity atlas of urban India, and it's an area which I can speak with some authority. Now, first let me say, what is food security? Food security is achieved when all people at all times have physical and economic access to sufficient, safe and nutritious food to meet their dietary needs and food preferences for an active life. Now, on the basis of a discussion by Ganesh Prasad, from this definition, you would see that by food security, we do not just talk about availability of food grains. Food security is a multi-dimensional problem, and we have to discuss at least some basic dimensions of food security. We are considering three basic dimensions of food security. One is food availability, and second one is food access to food, and third one is absorption of food. Now, it is quite possible that the present situation in India clearly showcases the point that while we have 60 million food grains buffer as in our go-downs, we still have people who are going to bed hungry, and we still have incidents of starvation deaths in our country. So access to food, the power to purchase food, is an extremely important component of food security. And another important component is food absorption. We may have food grains available, we may have the purchasing power to buy the food, but unless we have clean drinking water and unless we have good sanitational practices, our system will not absorb the food. So for biological absorption of food in the system, there are certain basic requisites as clean drinking water, sanitation, etc. So we have basically looked at these three basic dimensions of food security, and now I shall discuss how the urban situation looks like. Before I discuss the details, let me just say one thing. Now, while food security is there in rural areas as well as in urban areas, there are specificities of food security in a city or a town or in urban India. Now, in rural areas, even today, we have some kind of a traditional support system which is totally lacking in urban India. Secondly, given that food grains are produced in rural areas, at least for security, this is also totally absent in an urban area. Thirdly, and more importantly, a large number of insecure persons in our urban towns and cities are rural migrants who come and settle down, who stay for short periods of time in our cities, and who are not recognized, in the sense who would not figure in our electoral rolls, and who will not have ration cards, etc., to get them the benefits of some subsidized food grains from our PDS. So these are some of the specificities of food insecurity problem in urban India. Now I'm going to discuss how does this problem of food security look across different types of towns, across different size classes of towns in India? Now in India, we have in 2001, about 5,000 and odd towns have been counted. Of this, we have about 27 metro cities accounting for 1/4 of the population. Now small towns, which are those below 50,000 population, are as many as 4,000. Nearly 80% of our towns in our country are small towns which are scattered around the country, accounting for slightly more than 1/4 of our population. Now, how does the situation look across these different types of towns? Now, it's important to make a distinction between metro cities and small towns, because factors that have an implication for food security also vary from one type of town to another. For instance, when we talk about access to food, what is the level of regular employment? What is the level of casual employment? If we assume that if a worker has access to regular employment, which fetches him a regular salary and regular wages, then his food security position is slightly better than a person who's employed as a casual labor. Then we find that because opportunities are different across these size classes of towns, we find that the problem is also different across different types of towns. You can make out that out of 1,000 workers, nearly 221 workers in small towns are counted as casual labor. And this is double the percentage that is there in the metro cities. So the deprivation faced by workers in terms of regular employment is much more in the small towns. And when we look at basic literacy level, we do not have basic educational levels across different size classes of towns. But if we use literacy level as a proxy for educational levels, then we find even here the literacy level in small towns is much lower than the literacy level in big towns. And if we look at the difference between the male literacy and female literacy, we find that the gender gap is very huge in towns of our country. And when we look at some basic amenities which help in the absorption of food, we again find that just about 70% of our families living in the small towns have access to safe drinking water. Even in the metro cities, it's just about 90%. 10% of households, which is a huge size of population, do not have access to what we call as safe drinking water. Now this is true when we look at all the other amenities I have listed. And nearly 10% of our households in small towns do not have access to any of these basic amenities, safe drinking water or toilets or electricity. Now when we look at the basic infrastructure that is there in our country, you find there are just about 2 beds per 1,000 population in the small towns of our country. So all the indicators that we have taken, namely employment and the basic amenities and literacy level, clearly showcases the point that there is a very acute problem in the small towns of our country. Now what do we do about this? When we understand that there are problems in the small towns of the country, now the food grains that we have can be used to create the infrastructure. We've even mapped about what is the magnitude of this problem across the country has been mapped in our atlas. Food grains that is there can be used for Food for Work program to create these basic infrastructure across our country. And since the problem, there are about 4,000 and odd small towns across the country, and the nature of the problem varies a great deal across the country, we also have to have a decentralized policy approach to tackle these problems. And just one last point, it is while I spoke about the urban problem, the urban problems cannot be seen in isolation from the rural problem. So we have to have an integrated approach. We have to have area planning, which has to go together with the rural planning and urban planning.
What I'm going to say in the next few minutes is trying to argue that to ensure our security, food, nutrition, environment, and even economic security, it's extremely important to increase the productivity and the quality of our agriculture through the infusion of technology, and in particular agricultural biotechnology. And it's also important to make sure that the fruits of such development, everyone in this country is given an opportunity to share the fruits of such development. I just wanted to illustrate the importance of agriculture in this country. You know, it contributes over 25% of our GDP, and more importantly, almost 2/3 of all the people, all the working people in this country are engaged in agriculture. If we can move on, we have huge areas of arable land. India is fortunate to have both the climatic conditions as well as the land where we can cultivate huge amounts of crops. To illustrate this with the example of rice, if you take rice, we have over 43 million hectares under rice. And you may have to put and maybe a few more countries to get the kind of area that we have. So rice, if you take cotton, we have the largest area, several other important cereals, millets and other crops. But when you look at productivity, we rank way close to the bottom. So again, the important challenge, and how much do we need to actually produce? To meet the needs for the next 25 years, if you just take rice, we will have to produce close to 40 million tons. That is, increase the production in this country by close to 40 million tons. And how can we do it? And that's the challenge. In the past, if you look at our recent history, the infusion of genetics and plant breeding into agriculture, the development of the high-yielding varieties has done us enormous amounts of good. We have been able to belie, I think countries like India and similar geographies have been able to belie the Malthusian predictions of famine and chaos by actually increasing the productivity. But in the 70s and 80s, if you look at the increase in productivity of most of our cereals, it has been 3% or over 3%. But what's been happening in the last decade? I have just analysis on the data that was available for the decades of the 90s. If you look at the productivity increases in rice, it is in the latter half of the 90s, it is just about 1.5% increase every year. And let me remind you, my dear friends, that in this country where the population, the average rate of increase in the population is close to 2%, this is cause for great concern, and rice being the major staple in this country. Now how can we now break this yield barrier? The easy gains of the Green Revolution, in my belief, has been harvested, and we need another pulse of technology to actually break this barrier and then go forward. Let's again fall back on the history of agriculture. The productivity increases, and the improvements in the quality of the agricultural produce has often come through infusion of genetic technology or the improvement of the genetic makeup of the plant. If you look at historically, the genetic modification or the genetic improvements of plants probably started with the very advent of agriculture. If you look at the history of the evolution of maize, it is the progenitor of maize, teosinte. Through human selection in the Mayan and the Incan civilizations, you can see how maize has evolved. In fact, you see the maize that we see on the push carts, often in our streets, the butta, the changes are so dramatic. In fact, I think it's much more dramatic compared to any changes that can probably happen due to genetic engineering or genetic modification, what we term in the recent years. Now, an infusion of technology is extremely important. Now, the whole process of genetic modifications of plants and animals, or what you may call as plant breeding, changed. It became faster with the discovery of the laws of genetics proposed by Mr. Gregor Mendel at the beginning of the last century. And we have seen remarkable increases in productivity in our country in similar geographies due to genetic enhancement of crop varieties using plant breeding. Plant breeding became more of a directed approach, from the selections and the kind of art that it was being practiced earlier, it became a deliberate activity and we could reach the increased productivity levels that we see today. But as I told you earlier, we are now reaching the level of saturation. The easy gains have been harvested. We need more technologies and more products on the shelf. And I would like to strongly argue that agricultural biotechnology is an option here. Now, how did these improvements, just to illustrate to you how these improvements through plant breeding happened, once you know the laws of segregation and genetics, I would like to take the example of a flower, carnation, because Bangalore being a city of parks and of flowers and flora, I thought this would be a good example. Now, if you had two varieties, one variety which has got a longer stalk, a red flower, the other one which is a shorter stalk but a white flower, and if white flower is the desirable trait and you want to improve the stalk length, you could actually go ahead and cross these two. And what do you expect? You can expect the progeny to segregate into various different phenotypes. And these segregation, the proportion of these different phenotypes can be expected by the laws of genetics. And by applying strict selection criteria, by selecting for those ones that you are desirable, you can reach your objective of having a long-stalked, white-flowered carnation. So most of the varieties that we grow today of rice, say IR20, IR8, CO43, all these varieties have been evolved through a similar process. Now, implied in the application of such technology is the fact that you should have been able to cross between those two varieties or the original two carnations, and it is also important to have the variability for the trait. In this case, it is the length of the stalk. So you had a tall stalked carnation and a short stalked carnation, you could cross it and then evolve a white flowered carnation with a long stalk. Now assume for a moment that you didn't have this variability. All the carnation growing in this world were all short stalk. Now what could you do? If you are a little imaginative, you can look around and see if there is a coconut tree nearby. But my friends, you all realize how difficult it is to persuade a carnation to make love to a coconut tree. And this is where the tools that were developed in the last couple of decades, the tools that were developed for genetic transformation, plant genetic transformation, essentially overcomes the limitations to plant breeding that is caused by reproductive isolation. So now you have Bt cotton, in which a gene from a microbe, the Bacillus thuringiensis, has been transferred to make it insect tolerant. So what is the promise and what is the power of such technologies? We can keep talking about those technologies which have been commercialized, like the enhanced shelf life tomato, to the healthier oil producing canola or other crops, to Bt crops, and also to those which are a little more into the future, like the vitamin A enhanced rice, the edible vaccines about which, and also more recently what we call as biofarming. You produce biologically active molecules which will have important uses in the health and the treatment of disease conditions. So we are moving into those eras. So these are the promises of biotechnology. Now if you look at the genes that have been used to produce some of these plants, one thing is common. Most of these genes have come from microbial sources, the utilization of microbial genes, except in a very few examples. If you take conventional plant breeding on the other hand, most of the time you see that the genes from within the plants itself have been used. Just to cite a famous example, the DGOVU gen, the dwarfing gene, is probably present in all the short-statured, high-yielding varieties of rice. The next wave of biotechnology products, the first products of course focused on input traits like insect resistance, herbicide resistance and things. The next wave would essentially impact output traits like yield and also tolerance to environmental stresses. And where are the genes for these improvements going to come from? And most of them, in my understanding, is going to come from the plants itself, from different plant species. And this is where tools like plant genomics is going to help. Last year has been a very, very significant year. The most important crop in this world, rice, its genome, a draft sequence of it was published sometime in April in this journal Science. Now about a couple of months back we had the public program publishing 2 chromosomes, the sequences of 2 chromosomes, number 1 and 4, and more recently we also heard it from Professor Akhilesh Tyagi that the complete sequence has also been announced by the International Rice Genome Sequencing Consortium. It is also gratifying to note, and the participation of the various countries in the sequencing effort, you can actually see India's flag down there. So that's the portion of chromosome 11. This is just to put it in perspective, our contribution in the total world effort. But what is important is, the genomics efforts are going to give the leads for crop improvement in future. Now, there has been a lot of sequencing effort. If you take Arabidopsis, for example, Arabidopsis is a model plant. It is probably one of the best sequenced genomes that we have today among plants. And when people try to look at the functions of all those predicted genes, they still find that almost 40% of the genes are in the unknown category. That is, you really don't know what their functions are. It is important now, in future, the next stage of genomics, from structural genomics when you were actually looking at the sequence, to move on to what is called functional genomics, that is assign functions to these genes of unknown function, or the unknown genes, so that the really valuable genes, which could be of use in improving productivity, in improving stress tolerance for the plants, could be within this category of unknown genes. So that's where genomics is heading, as far as while the sequencing efforts are continuing, the efforts are also progressing, is also proceeding towards assigning functions to unknown seeds. So what is the status of GM crops in the world? Almost 52.6 million hectares. This was in 2001, was under GM crops. So I was trying to do a quick mental calculation. The area of our country is 2.26 million square kilometers or something. So that represents almost 17% of the total area of this country. So that's a huge amount. And if you look at the number of incidents where either people have died, and let me also tell you, millions of people are also consuming GM products. This just goes to testify the safety record of GM products. Let me just try to quote from Norman Borlaug, who is the Nobel Peace Prize winner. And too many opponents of biotechnology too easily dismiss the many safety and regulatory checks that govern whether a new agricultural product is brought to the marketplace as worthless. Unfortunately, they willfully choose to emphasize highly unlikely potential risks rather than recognize the years of experience, research, and regulatory oversight that governs the safe use of these new technologies. So, 2 messages here. 1, it is important to practice responsible biotechnology. And number 2, it is important to have good regulatory systems which will promote responsible biotechnology. So let's see the factors which will promote responsible biotechnology. It's extremely important to demystify biotechnology, probably start with education of the school children. The media has a very important role to play. I'm sure we are all interested in BT cotton because it got deregulated or released last year, and we want to see how it's performing. I was just scanning through the newspapers, and the first one says, no desired results from BT cotton. The Hindu the same day says, new BT cotton crop has not failed. And here you have a responsible person in the government saying, there have been no major profits from the BT cotton except that we have saved on pesticides. My friends, that is what I would have expected. If you wanted BT crops, the BT crops is essentially, it saves on pesticides. And particularly in BT cotton, where more than 50% of all pesticides is used in cotton, isn't that a good benefit? I think we need to evaluate that. The same day, another minister, who is a central minister, has said, the special monitoring committee set by my ministry in each of the 6 states where the crop was planted had found that the performance was good. I think, the general public, unfortunately in this country, or fortunately in this country, the media, both the print media and the visual media has a tremendous reach, and many people get information from those. But this kind of reporting essentially help to muddle the whole issue rather than presenting the right picture. I just want to list, I'm not going to explain in detail. I think we need to have an extremely efficient regulatory system to promote responsible use of biotechnology. In fact, the regulatory system should prevent the misuse and abuse of this technology. It is important to have competent people. Thankfully, we have extremely good rules and regulations, but we are often found wanting when we come to implementation. Biology is not all black and white, so we need technically competent people to make the right kind of judgments. We need to have productive public-private partnerships. its involvement of stakeholders. It's extremely important to involve farmers in this whole dialogue. Why can't we have farmers or their views in the committees or in decision-making bodies where we actually do? The farmers who actually did some of these trials on these transgenic crops. It's extremely important. It's extremely important to have political and policy initiatives which will promote investment in biotechnology and which also will kind of make sure that the investment in biotechnology is protected by proper intellectual property protection regimes. This is a quote from the person who received the Nobel Prize just about a month ago, the most recent Nobel Peace Prize laureate, the former President of the United States, Jimmy Carter. Responsible biotechnology is not the enemy, starvation is. Without adequate food supplies at affordable prices, we can't express world health or peace.
विश्व वैश्विक महामारी से ग्रस्त है। आयुष मंत्रालय की तरफ से सेल्फ केयर गाइडलाइंस जारी की गई हैं ताकि लोग सांस से संबंधित बीमारियों से अपना बचाव कर सकें। खासतौर पर इस समय लोगों के बीच कोरोना वायरस का डर बहुत अधिक बना हुआ है। इसके चलते लोग सेहत संबंधी तरह तरह की अफवाहों का शिकार हो रहे हैं, जिन्हें रोग प्रतिरोधक क्षमता बढ़ाने वाली टिप्स के नाम पर प्रचारित किया जा रहा है। देशवासियों की सेहत को ध्यान में रखते हुए आयुष मंत्रालय द्वारा कुछ आयुर्वेदिक विधियां सुझाई गई हैं ताकि लोग गलतफहमियों का शिकार न हों, सेहतमंद रहें और अपनी इम्यूनिटी बनाए रखें। कुछ सामान्य तरीके आयुष मंत्रालय द्वारा ऐसे सामान्य तरीके सुझाए गए हैं जिन्हें हर किसी को अपने दैनिक जीवन में शामिल करना चाहिए। ये तरीके हम शरीर को स्वस्थ रखने और रोग प्रतिरोधक क्षमता बढ़ाने में मदद करेंगे। पूरे दिन जब भी पानी पिएं तो गर्म पानी का ही इस्तेमाल करें। योगासन, प्राणायाम और ध्यान हर दिन कम से कम 30 मिनट तक जरूर करें। हल्दी, जीरा, धनिया, लहसुन का उपयोग खाना बनाने में करें। हर दिन 1 चम्मच च्यवनप्राश के साथ सुबह की शुरुआत करें। जिन लोगों को डायबिटीज की समस्या है वो शुगर फ्री च्यवनप्राश खा सकते हैं। हर्बल टी या काढ़ा पिएं। इसके लिए तुलसी, दालचीनी, काली मिर्च, अदरक और मुनक्का को एक साथ पानी में उबाल लें और छानकर इसका पानी के साथ सेवन करें। ऐसा आप दिन में 1 से 2 बार कर सकते हैं। अगर आपको इस काढ़े को पीने में परेशानी आए तो टेस्ट के लिए आप इसमें गुड़ या नींबू का रस मिला सकते हैं। और साथियों, आधा चम्मच हल्दी को 150 ml दूध में मिलाकर दिन में 1 से 2 बार पी सकते हैं। ध्यान रखें कि इससे तुरंत पहले या इसके तुरंत बाद खाना नहीं खाया होना चाहिए। आपको बता दें कि तिल का तेल, नारियल का तेल या देसी घी अपनी नाक के दोनों सुरों में लगाएं। ऐसा दिन में 2 बार करें, सुबह नहाने के बाद और रात को सोने से पहले आप ऐसा कर सकते हैं। 1 चम्मच तिल का तेल या नारियल का तेल मुंह में ले लें और इसे मुंह के अंदर ही अच्छी तरह से घुमाएं। ऐसा आपको 2 से 3 मिनट तक करना है और इसके बाद इस तेल को थूक दें और फिर गुनगुने पानी में कुल्ला कर लें। ध्यान रखें, आपको ये तेल पीना नहीं है। इस प्रक्रिया को भी आप दिन में 1 से 2 बार कर सकते हैं। इस प्रक्रिया को कवल ग्रह नाम से जाना जाता है। पुदीने की पत्तियां और अजवाइन लेकर इन्हें पानी में उबाल लें और इस पानी को भाप लें। इससे आपको लाभ होगा। अगर आपको कफ या गले में दिक्कत हो तो लौंग का पाउडर शहद या चीनी के साथ मिलाएं और दिन में 2 से 3 बार इस मिश्रण का सेवन कर सकते हैं। और याद रहे, इन बातों का खासतौर से ध्यान रखें। ये तरीके सामान्य तौर पर होने वाली सूखी खांसी या गले के दर्द की स्थिति में अपनाए जाने चाहिए। अगर इसके बाद भी आपको शरीर में ये लक्षण बने रहते हैं तो आपको तुरंत डॉक्टर की सलाह लेनी चाहिए। साथियों, आप सुन रहे हैं ज्ञानवाणी दिल्ली FM 105.6 मेगाहर्ट्ज पर ज्ञानवर्धक और शिक्षाप्रद कार्यक्रम ज्ञानवाणी दिल्ली पर। अब वक्त है हमारे अगले कार्यक्रम का। अगला कार्यक्रम है साप्ताहिक पत्रिका। आइए सुनते हैं ये कार्यक्रम।
शिक्षा के द्वार पढ़ी लिखी और बनी खुशहाल, ज्ञानवाणी का उद्देश्य सफल। ज्ञानवाणी।
नमस्कार श्रोताओं, साप्ताहिक ज्ञान पत्रिका के इस अंक में आप सभी का स्वागत है। मैं हूं तरन्नुम जहां। हर हफ्ते इस कार्य
योगदान दिया और इस यूनिवर्सिटी को अपने पैरों पे खड़ा किया और उस जर्नी को कंप्लीट करते हुए यूनिवर्सिटी यहाँ तक आई है जिसके पास आज की डेट में 30 बीएड कॉलेजेस हैं एंड इस यूनिवर्सिटी का पूरे बिहार में ज्यूरिसडिक्शन है। तो ये 30 बीएड कॉलेज हमारे पूरे बिहार में है। हमारे पास आज की डेट में 140 नॉलेज रिसोर्स सेंटर्स हैं केआरसी, और उस केआरसी में हमारे पास वोकेशनल कोर्सेज हैं, 11 वोकेशनल कोर्सेज हैं जिसमें 3 इयर्स बीबीए, बीसीए एंड बैचलर ऑफ जर्नलिज्म एंड मास कम्युनिकेशन। इसके अलावा हमारे पास डिप्लोमा कोर्सेज हैं, बैचलर इन लाइब्रेरी एंड इंफॉर्मेशन साइंस, और उसके अलावा हमारे पास छोटे छोटे कोर्सेज हैं जो कि 6 मंथ्स के सर्टिफिकेट कोर्सेज हैं, जिसके बारे में मैं आपके माध्यम से बच्चों को बताना चाहूंगा कि डिप्लोमा इन पंचायती राज ये सर्टिफिकेट प्रोग्राम सिर्फ इसी यूनिवर्सिटी में है। एंड पिछले 5 साल में ये देखा गया है कि काफी वैकेंसीज निकली डिप्लोमा इन पंचायती राज की, तो वो डिप्लोमा पंचायती राज जिन्होंने किया था उसको एज रिलैक्सेशन भी मिला था।